All right, 7.3, adding and subtracting radical expressions. Now, the way I do adding and subtracting radical expressions is, he's gone. I don't know where you are. He's not in the hall. He is. But he left. All right, so the way I think of this is those radicals I kind of view as like a variable. In order to combine them, they need to be the same. If they're not the same, I can't combine them. So Chris, do you see how in A up there, they all have root 7? Kind of view that all as like halves, okay? So it says x plus 5x minus 2x, right? So x plus 5x is 6x, minus 2x is 4x. Agreed? That is the same as this. All right. Root 7 plus 5 root 7 is 6 root 7. And then I have minus 2 root 7. That's simply 4 root 7. Do you see how it's very similar to the variables? All right. Now in B, Justin, we have two different variables going on. We have the root x, so those can be combined. And then I have the cube root of 4, which can be combined. Now, I have 6 root x minus 5 root x. Justin, let's think of it this way. If I have 6x minus 5x, what would that be? X, right? So 6 root x minus 5 root x is just a root x. Is that okay with you?
How many classes?
I think it's like 2 or less. We'll talk at the other class. We'll make sure you're good. Okay. Now, Justin, we have negative cube root of 4 and positive 2 cube root of 4. That is correct. Not bad so far, right? Pretty straightforward. All right. And in C, we have 3 cube root of x plus 2 cube root of x plus root x minus 8 root x. All right, Leah, I think it's fairly easy to see we have what? What would our answer be? 5 cube root of x. Would be minus 7 root x. Do you see the difference? This one's cube root of x, and this one is just root x, okay? Can be confusing. Seven, 3. Okay, so Jake, just to recap you on this, okay? We're going to view these roots kind of as variables, okay? So don't freak out on this, Jake. So in A, we have root 7 plus 5 root 7 minus 2 root 7. I was saying to Chris, view it as like x. X plus 6 or 5x is 6x minus 2x would be 4x. So here, root 7 plus 5 root 7 is 6 root 7 minus 2 root 7 is 4 root 7. Make sense? And then in B, we have x's and y's. So when I was talking to Justin, we have 6x minus 5x. That would just be x. So here, if we have 6 root x minus 5 root x, that's just root x. Yep. And then negative root 4 plus 2 root or cube root of 4 is just cube root of 4. Now, this is where it gets a little funky, but it's actually not bad. Okay. So we have the square root of 45x plus 3 times the square root of 20x. Now, J, they're not the same, are they? So what I need to do is I need to break them down to actually see if they're the same. Now, the reason why I have to break them down is like I could have perfect squares in there that I could pull out. Make sense? So Jay, what two numbers go into 45? 9 and 5 is great because 9 can be broken down to 3 and 3. All right. Now, the square root of 45x can be written as 3 because that 3 came out, root 5x. Jay, do you see that? Now, can you break down the square root of 20? What was it? 10 and 2, okay. 10. 5 and 2. There's your pair of 2s. I'm going to pull that out. Now it's going to be 3 times 2 because the 3 is outside. See that? So it's going to be plus 6 root. The 5 didn't have a partner, so it stayed inside x. Now, do you see how they both have the same variable here, Jai? What would that be? 3 square root of 5x plus 6 square root of 5x is? Not too bad. 3 times the 2 that comes out. 3 times 2 is 6. Hansi, what the square root implies what? Like a cube root implies like I'm looking for like groups of 3, right? But that one always has like a 3 outside or something like that. Agreed? Yeah. What does square root imply? 2. All right, now I know it seems kind of silly, but we're kind of implying that there's a 2 out there. Now, why is that significant? Because this 2, we're going to see how many times it goes into the 3. 2 goes into 3 how many times, Hansi? Once. All right, so 1x comes out and 1 is left in. So I simply did 3 divided by 2 is 1 with 1 left over. So 1x came out and 1 stayed inside. Make sense, Hansi? You told me it. Yeah. Square root implies 2. So there's never going to be a 2 here, Hansi. There's never going to be a 2 there. All right? It's always there. It's always implied. All right. If I was talking about a cube root, then I would put a 3 there. If I was talking about a 4th root, I would put a 4 there. But square roots never have it. Okay. So I have 5x minus x. Ooh. What's the 4, right? What's the square root of 4? 2. So instead of writing just x, I'm going to write 2x root x. Does everybody see where I got that from? Nikki Grantland? What's the square root of 4? 2. So I pulled the 2 out. The x was left inside. Why? Because I want these to be the same. I'm trying to simplify it, as you said, Jake. And the only way I can simplify it is that if those radicals are the same. If they're not the same, there's nothing I can do. Okay. So Hansi told me square root implies 2, right? So if there's an implied 2 out here, the way I deal with variables, I can take the square root of number, that's easy, right? But variables, what you do is you take your radical power, which in this case is 2, and I divide it into 3. How many times does 2 go into 3? 1 time. So 1x came out. And 1 stayed inside because there was 1 left over. Always a 2. It's always implied. Cody, you okay with that? Yeah. Now 5x root x minus 2x root x is simply 3x root x. Carlotta, are you okay with this? Not bad, right? Now, Hansi, remember how I told you it's implied that a 2's there?
Yeah.
See how this one has a 3?
Yeah.
So the 3 is there. The difficulty with this is actually the number part, okay? The numbers are gonna be the hard part because I'm looking for groups of 3, as you told, right? So Hansi, can we break down 54? Just 2 numbers that go into 54.
2 and
That's okay, you can start at 2. 2 is great because as long as you can find one number that goes into it, we simply do 54 divided by 2, that gives me 27. See how I did that? Give me one number that goes into 27.
3.
3. Then I do 27 divided by 3, that's 9. Give me a number that goes into 9.
3 and 3.
Now,
And there's our group of 3.
there's your group of 3. All right, I'm gonna hold off on that for now. Can we break down 2?
No.
No. So I'm ready to tackle this problem. All right. So let's clean up this first piece here, this first radical. We pulled out a group of 3's from the 54. So the 3 goes outside. The cube root is just part of the problem, right? See that, Nikki Grantland? It's just a cube root. You're gonna have stuff inside and outside of it. Outside is the 3, because we had a group of 3's. Inside is going to be a 2, because he has no partners. Do you see that? Lance, you good with that? Julia? Okay. Amelia, you okay with this?
Yes.
Now, ready, Nikki Grantland? That's a 3, right? How many times does 3 go into 5? Once. With how many left over? So it's y squared. Breakdown? No. Great question. Nikki Grantland said, what if I broke down 54 to 9 and 6? Just to drive Hansi nuts. He's like, what is 2 and 27 not good enough for you? No, it's a great question because if you saw 9 and 6, that's okay. 6 breaks down to 2 and 3, and 9 breaks down to 3 and 3. So at the end, you still are left with 2, 3, 3, 3. See that? Yep. Cube root means I'm looking for a group of 3. If there's a square root, I was looking for a group of 2. Fourth root, I'm looking for a group of 4. Okay? Now, that's 3y times the cube root of 2y squared plus. Now let's look at this. Over here. All right, that looks like it's what? A y squared. Can 3 go into the 2? No. So I simply just have 4 times the cube root of 2y squared. Can everybody see that? Now, is there anything I can do with that? Well, I can't really combine them, right? But I can. See how these are the same? Can't cross them out. I can factor it out. Okay. I can kind of undistribute it. Okay. Do we see how both of these have the cube root of 2y squared in common? I can pull that out. And what's left? Well, what's left would be the 3y plus 4. Nikki Granlund was like, I was doing so well. And then you pull one of these.
I'm thinking the same thing.
Hansi, that's because you have 2 left shoes on today.
2 left shoes on.
You had a look.
No, I did not.
You did. Do you held up your
I
feet?
wanted to prove you.
No. Well, you held up your left shoe,
I held
so
up both of my shoes.
I can't see that one. It's dirty.
No dirtier than your shoes.
That's right. I get my money's worth out of my shoes.
Me too.
All right. All right, D says the cube root of 6x to the fourth plus the cube root of 48x minus the cube root of 162x to the fourth. Lance, did I read it right? I know it's a little blurry, right? It's good. Okay. I believe the appropriate term is it's Gucci. Okay. Like getting Devontae Smith at number 10. It's pretty nice move. All right, Lance. Let's focus on the first one. Just you and I, okay? Cube root. Can we really take the cube root of 6? No, you can't really break down 6 any further, right? Because 6 would break down to like 2 and 3, and there's nowhere we can really go from there. So let's figure out how many times does 3 go into 4? 1 time. So I pull out 1x, and what's left? An x. So the 6x is going to be left on the inside. Are you okay with that, Lance? All right, Kailana. Let's break this down, okay? Can we break down 48? What number is going to 48? 2 and 24. What number is going to 24? 4 and what? 4 and 6. 4 is easy, 2 and 2. 6 is easy, 2 and 3. Do we have a group of 3? Yeah, I'm going to circle these right here because they're easy to say, right? Doesn't matter which 2's you group. So I'm going to pull a 2 out. And then left inside my cube root is going to be a 2 and a 3, which is 6. Are you okay with that? 2 and 3 is 6. Can I do anything with the x's? No. So it's just 2 times the cube root of 6x, which is good because if you look at these, see how they both have cube root of 6x? So it's looking good. All right, Justin, let's deal with 162. Give me 2 numbers that go into 162. Give me 2 numbers that go into 81. And that's a good one to pick because 9 breaks down to 3 and 3. So there's a group of 3, right? So I have my house, this cube root house. The group of 3 comes out. Left inside is a 2 and a 3. That's 6. All right. Now, Justin, how many times does 3 go into 4? Once. So I'm going to pull out 1x, and then how much is left? So now this looks great because I have x times the cube root of 6x. And then I have a 2 cube root of 6x and a 3x cube root of 6x. That looks good, right? So let's go ahead and do the problem. So we have x cube root of 6x. And then we'll do plus 2 cube root of 6x minus 3x cube root of 6x. All right. Now, obviously, Justin, we can combine the blue and the red, right? Because they both have that x on the outside. I can't combine the 2 or the green piece because it doesn't have the x. So blue and the red give me negative 2x cube root of 6x plus 2 cube root of 6x and then because they both have that cube root of 6x, I can just pull that out and I can write it as negative 2x plus 2 times the cube root of 6x, or yeah, 6x. You guys okay with that? Feeling you all right? Soaking it in? Yeah. Soaking it in like the Eagles soak in those losses. And those Phillies. What?
You got Smith.
Yeah, he's only good at like wide receiver, like that 10.
Yeah.
You ain't picking him at the 6. I wouldn't touch him at the 6. It's like I would go Jamar Chase, Waddle, or like Pitts. Like you're gonna get one of them. Bigger receiver. We need a bigger receiver. All right. Bigger, stronger, more aggressive. It'd be nice if we had DK Metcalf, but like you can teach players. You can teach players like DK Metcalf to go run routes and catch the ball, but you can't teach size and genetics. All right. So, and we'll see. Like he could be good. He could be great. Love it. Love the pick at 10. But when you have like your choice, you gotta.
So you would rather have Chase or Waddle?
Waddle. I don't know because Waddle didn't play last year.
He's only like 5
He's still a little bit bigger. I'd probably take Smith over him, but like, you know what I'm saying? At least you have choices. Like we didn't have a choice. It was already taken off the team. So, well, I would pick problem number E, but I would probably would have picked Chase, but I don't know because he hasn't played with, Jalen Hurts. It's good chemistry. You already have that chemistry between Hurts and Smith because they play together. All right.
The cat kind of this one?
Now, well, this one's different. Okay. Now in E, we have to do something called rationalizing the denominator. Okay. We can't divide by root 7. So we have to rationalize the denominator. Do you guys recall how to rationalize the denominator? Okay. So in the denominator, we have to get rid of that root 7. So what we're going to do, okay, is I'm just going to multiply by root 7 over root 7. So this is going to be root 7 minus 5 root 7 over 7. Do you guys see that? Now, Hansi, in short, when I'm rationalizing the denominator here, okay, notice it's just a square root. I'm going to add a root 7 and divide by a root 7. You see that? So add a root 7, divide by 7. See that? Kind of like a little, I guess, like shortcut. See how I'm adding the root 7 to the top and dividing by 7? Okay. Trying to find a way to give you a little edge. All right. You sure you're okay?
Yeah.
Staring at me kind of hard. It's like you're peering into my soul and judging me.
I'm paying attention.
That's good. Now, Jake, we're still not done this problem because we have to combine these two. Now, if I view these as fractions, notice this doesn't have a denominator, does it? So I have to make a denominator, right? So how do I make a denominator? What's the common denominator here, Jake?
7.
7. So we would multiply this by 7 over 7. That gives me 7 root 7 over 7 minus 5 root 7 over 7.
And now they're even. They can just add them.
We're combining, yeah. So that would be 2 root 7 7. You guys okay with that? Carolina? You seem like you're a little puzzled. Was what? It was.
I didn't.
Oh, okay. Yeah, so here I have to rationalize the denominator for the second part. You guys can pack up while I'm going over it if you want. I had to rationalize the denominator by multiplying by √7 over √7. That gave me √7 minus 5 √7 over 7. But now because they're fractions, I can't combine them. So then I had to make a common denominator, which was 7. So I multiplied the √7 by 7 over 7. That gave me 7 √7 over 7 minus 5 √7 over 7. That gives me the 2 √7 over 7.
Wait, so